Alright, in this lesson I'll introduce the catch-all IX method. And the reason I use catch-all is because the IX method basically combines the functionalities of the loc and iloc methods. So it effectively captures all of the possible scenarios, whether we want to extract rows from a data frame based on the index label or the index position. It basically allows you to do either. So it's kind of this optimal method for when you kind of want to mix and match index labels or index positions. So it is my personal favorite pick. I know there is some debate on online places like Stack Overflow about the inefficiencies of this method and some of the potential problematic uses of it if depending on how your data frame is structured. But in this lesson, we're not going to have any of those kinds of issues, so I can show you how effective this method is in order to extract rows from your data frame. So let's begin by executing our import code to import our James Bond CSV. I'm also sorting the index there and previewing the first 3 rows with the head method. So let's begin by calling the IX method on my Bond data frame. And just like loc and iloc, it's going to take a pair of square brackets, not parentheses, at the end. And let's begin with an actual index label. So I'm going to enter GoldenEye, and I'm going to extract a series that represents the values for that row. So at this point, the IX method is basically functioning like a loc method. So I can do bond.loc and feed in the same value and get the exact same results. There's no difference. So IX can accept index labels. In this case, our index is made up of strings. We have no problem feeding in a string. And all of the other functionalities of loc are also available. So for example, if I want to pull in multiple values, I can do something like provide a list of those values. So I want to extract 3 rows here. Diamonds Are Forever, Moonraker, and Spectre. These are 3 Bond films in my data frame. So I'm going to extract a new 3-row data frame with those index labels. There's no problem there. I can also extract sequential values. So for example, if I want all of the movies between A View to a Kill, which is my starting position, and also through The World Is Not Enough, I can just use that colon in between my 2 string values, which represent the start of my index labels and the end of my index labels, and I'll pull in all of the movies between A View to a Kill right here, all the way down to The World Is Not Enough. The important thing to note here whenever you're using index labels is that this value on the right side of the colon, the endpoint, is inclusive. What that means is The World Is Not Enough is going to be included at the bottom of our data set. So this is going to be the literal start point, A View to a Kill, and The World Is Not Enough is going to be our literal endpoint. Now there is one caveat to this method IX. Well, first of all, of course, if we put in a value that does not exist, for example, Sacred Bond is not a valid Bond movie, it's not a valid index label in this data frame. Of course, if we provide an index label that does not exist, we're going to get an error. That's pretty familiar to us by now. But here's where it gets interesting. I'm going to comment this out to ensure we avoid this in future executions. But if I do something like the IX method and I provide it a list, and at least one of my values exists. So for example, Spectre, as we saw a couple examples above, is a valid index label. It's a real Bond movie. And afterwards, I put something that does not exist in the index, such as Sacred Bond, which we just saw above, resulted in a key error. Pandas is going to do something interesting. Because it matches Spectre, it's going to return that row right here. We can see it. But it's also going to return the other value that I provided to search for, Sacred Bond. Here you can see it listed. And it's going to return a row of null values, or NaNs. Now this is a little bit confusing because you might think that Sacred Bond is actually a valid row within my original Bond data frame, and it's just a row that has null values throughout. However, this index label, Sacred Bond, does not exist in Bond, period. We proved that just a couple seconds ago by running this code above, and we got no results. Unfortunately, when you pass multiple values into a list and at least one of them exists, Pandas is going to give us this design as the result. It's going to give us a data frame where the values that do match are going to have their row values extracted, and the index labels that do not match are going to have a row of null values. So that can be a little bit confusing when you want to check if something is actually valid and exists within the index or does not. Of course, to quickly check whether something exists in the index, we can always use that Python in keyword. We can do something like Spectre in bond.index, and that'll tell us true. And conversely, if we do something like sacred bond in bond index, that'll tell us false, it does not exist. So we can always use that method in order to check, but just keep that in mind whenever you're using multiple labels within a list for the IX method. So far I've shown you the IX method, and we've been giving it string labels, so it operates similarly to a loc method. But what's great about IX is that it's flexible, and it can also operate exactly like a iloc method or an index location method. So instead of giving it a string value, I can give it an integer position that represents my index position. So here is going to be the index position with a row value of 10, which is again going to be my 11th item or my 11th row in my data frame. You can see that movie is License to Kill. I can similarly do something like extract values sequentially by doing something like 10 through 15. Now here's where it gets a little bit interesting. In the example above, when I did this thing, remember how I talked about the fact that the second value was inclusive, so the world is not enough was included at the bottom of my data frame. In this case, whenever we pass integers, this second value is exclusive. So this index is going to include, or rather the data frame that we see down here is going to include 10, 11, 12, 13, 14. So it's going to include all the index positions up to 15, but not including 15. So that's a big difference whenever we're passing index positions versus index labels, and IX takes both, so just be careful. Just because you're using a colon doesn't mean that the resulting data frame will be the same. Rather, it depends on whether you're passing integers or labels in this case. So let's do a couple other examples. Of course, we can extract multiple non-sequential values by passing a list. So within my square brackets after the IX method, I can just pass a Python list. So that's another pair of square brackets. And let's say I want movies 8, 16, and 24. And there we're going to get those 3 movies. Of course, if the index position does not exist, for example, we don't have an index position of 100, just like the IX method above with sacred bond, it's going to give us an error, in this case an index error, because it can't find it. But here's where it also gets interesting. So remember in this example where we got the result for Spectre but not for sacred bond because at least one of them existed in our data frame, it doesn't work the same way when we give an IX a list in which at least one of the values exists. So for example, if I pass a list of index positions 8 and 30, 8 is a valid index position and it exists within my data frame, but 30 is not. And although we have at least one of them match, this is still going to result in an error, another index error. So the way that this functionality works here is also different from how it works whenever we have index labels specified to the IX method instead of index positions. So there are a couple of caveats, and most of these, especially in my line of work, I didn't commit to memory. I just kind of figured them out through making the mistakes over and over again. But as you can see, IX basically combines the best of both the loc method and the iloc method. There are certain scenarios where you don't really want to specify IX and you want to stick with either loc or iloc, but I can let you do that research if you want to just Google or Stack Overflow loc versus iloc versus IX. You can find out what specific data frames each one is best built for, but generally kind of the big picture is for a normal data frame without any kind of missing values. An IX method is basically going to capture both the functionality of a loc method and an iloc method. So within those square brackets after the method, you can pass either an integer or a label or an index label, and either one of those will work. So that is the catch-all IX method available on a Pandas data frame.